The learning target we're going to cover is I can find the roots of a polynomial by factoring and using the zero factor property. So what we need to know, we're specifically going to be looking at quadratic equations, and a quadratic equation is written in the standard form as such: ax squared plus b times x plus c equals 0, where a, b, and c are all real numbers, and your first coefficient of a cannot equal 0. So that is our standard form of a quadratic equation. So here's some examples of what that might look like. Here is an example of a quadratic equation that's written in standard form. X squared minus 7x plus 12 is equal to 0. You have your entire trinomial, quadratic trinomial on the left side, and it's set equal to 0. Here's an example of something that is a quadratic equation, but it's not in standard form because I don't have all three terms of my polynomial on one side of the equation. So I'd have to move this 15 to the other side to make it in standard form. And then lastly, here's another example. This is not in standard form, but it's still a quadratic equation because if I were to go ahead and distribute that x out in this, when I multiply that x, I end up with an x squared and I'd have a 7x. So I'd have something similar to what we have here in our second example. But for our purposes, we want to be in standard form before we start solving our equation. Now, when we solve our quadratic equations, we're going to use what's called the zero product property. And I'm going to explain the concept and then we'll do an example so I can show you what it really means. So for every real number a and b, so if you have two numbers, a and b, they're both real numbers, when you multiply them together, so if I multiply a times b, if that answer is 0, that means that one of those two numbers has to be 0 because anything times 0 is 0. So a could be any number, doesn't matter what number it is, but if I multiply by 0 for b, I'm still going to get 0. So a or b would have to be 0 if when multiplied together they equal 0. So we can apply that same principle even when we have binomials. So if you pretended like this entire binomial here was a and this entire binomial here was b, if x plus 2 all times the quantity of x plus 3 equals 0, then we know that this first binomial, remember if we let this be a, would have to be equal to 0, or that second binomial b there would also have to equal 0, one or the other, or both, okay? So let's look at that, what that means when we're solving for our quadratic. Here's some step-by-step instructions for you as you're moving through while solving. So the first step is to write our equation in standard form. So that's the a times x squared plus bx plus c equals 0. We want to factor the equation completely. Then we're going to set each factor equal to 0. We're going to solve each equation. Those solutions are called the roots or the zeros of the equation, and then we can check the solutions back in the original equation to make sure we did the problem correctly. Step through with those steps there. So the first step, I'll start with my explanation here, my description on what we're supposed to do. So it says to find the roots of the quadratic equation. So the roots are basically your answer. You might also see the word zeros here. This just means that you're solving for x. All right, now when I do that, I want to make sure that first I want to make sure that I'm in standard form. I am in standard form here because I'm in the form ax squared plus bx plus c equals 0. So we've got that checked off the list. Now next I want to factor this completely. So you may have used some method. I've used the factor method here, or the x factor, where we take our last term here, the negative 48, and I want to know what multiplies to give me negative 48 that's going to add to give me negative 8. Okay, so when I'm looking for my multiples, remember we want to figure out what are factors of 48 that are going to add to give me that negative 8. So negative 48, you could start, sometimes it's helpful just to kind of make yourself a little list So factors of 48, if you started with like your 2, you'd have like 2 and 24, because 2 times 24 gives me 48. But I can see there that those are not 8 apart in any way, or that if we add them together, it would equal 8. So that's not going to work for me. You could look at 3 and 16. Again, though, if I add those together, I get 19, or they're 13 units apart. I want them to be 8 when I finally figure it out. So if I go down to 4 divided by, or 48 divided by 4 is going to be 12, and 4 plus 12 would give me 16, but 4 and 12 are only 8 units apart. So here's that 8 here. So I now need to figure out, okay, so what needs to be positive and what needs to be negative? So I need them, one of these has to be negative, because when we multiply them, it's going to give me a negative 48. But when I add, I want them to be negative 8. So I'm going to have this negative 12. I need that to be the bigger number, so that when I add 4 plus negative 12 or 4 minus 12, I end up with negative 8. So there's my two factors. So here's my second step. So I'd have x plus 4, and I'd have x minus 12. Okay, now this is all set equal to 0. All right, so now we're going to go ahead and we're going to solve this equation to figure out what x is. So here we're using our zero product property. Okay, remember, if I have two numbers that multiply to give me 0, one or both of them is going to be equal to 0. So I can set x plus 4 equal to 0 to see what would x have to be in order for this first term, or this first binomial, to be 0. And again, I'm going to do the same thing for that second binomial. I'm also going to set it equal to 0. And then we're just going to solve these two equations separately. So x plus 4, I would end up having to subtract 4 from both sides by doing the inverse there. So x is going to equal negative 4. And then here I have x minus 12. So to undo that subtraction, we're going to have to add. And I'd end up with x equals positive 12. So those are my zeros, or my roots, for this quadratic equation. So I could write my answers out in a pair, x equals negative 4 and 12, so I could list them as such. And then we could go back and then check our work by plugging in those answers into my original equation. So if I plug in negative 4 into my equation, you can just type this in your calculator as you see it, and you will end up with 0 equals 0. Okay, so that would pan out. And then you would do the same thing with your second answer. And when I plug all that in my calculator, just like I see it, make sure you use the parentheses here so that the negative is computed correctly in your calculator. Again, you're going to end up with 0 equals 0. So you should get 2 true statements as long as you did your question correctly. All right, so now would be a great time for you to pause, try this on your own, and then come back and check your work with us in a second. So we're going to go ahead and work through this one. We want to find the zeros of the quadratic equation. That just means we're trying to find out what our variable is. There's going to be 2 because we've got p squared, so we're finding 2 values for p. We're already in standard form. We want to double check that. Oh, my pen is going crazy. We want to check that we're in standard form when we start, and we are, but I'm just going to write it here just as a reminder. Okay, that's our ax squared plus bx plus c equals 0. Okay, so we're there. And then we're going to go ahead and factor. So I'm going to go ahead and list out my x factor. So I want to know what multiplies to give me negative 18, that adds to give me positive 3. Okay, so I know I've got like 1 and 18, but those aren't 3 apart. I've got 2 and 9, that would add to give me 11, or they're 7 units apart. But then I've got 3 and 6, and 3 and 6 are in fact 3 units apart. I need the 3 to be positive when I add, so that means that my smaller number is going to be the negative, which means my 6 would have to be the positive. So p, not x, I'm so used to writing those x's, p minus 3, and then p plus 6 are going to be my two binomials. Now that I have it factored, I'm going to go ahead and solve. So we set each binomial equal to 0, and we solve them separately. So right here I've got -3, so we're going to add 3 to both sides. And p is going to equal +3, and then here we're going to subtract 6 on this side because I was adding. The inverse of addition is subtraction. There are my two answers for p. So p equals 3 and -6. Again, we can check our work by going back to our original quadratic equation, and you can just plug in 3 for p and -6 for p. And when you do, you should get 0 both times. So I'll just write it out for you so you can go in and test in your calculator. Okay, and when we do this first one, when you plug all that in, you should get 0 equals 0. And then the second one, same thing. If I substitute in my -6 value for p, I want to make sure that the whole left side in fact equals 0. When you plug all that into your calculator, 0 will equal 0. Therefore, we solved this correctly. If you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.